I'm Tim Spann, Principal Developer Advocate at Cloudera. My talk is how to do cloud native Apache Pulsar development. And this is a follow-up to last year's. And I'll also show you a little bit on what you could do with Python with Kafka, MQTT, and some other streaming protocols. If you want to learn more about these technologies, you want me at one of your events, you maybe come to a meetup, look at my mailing list, all my contact information is here, and the event will give you all the slides, so you'll be good to go. Got a weekly newsletter, covers all the streaming tech, plus Python, different languages, lots of open source tools. Comes out every week, very non-intrusive, and I also put it all in GitHub if you don't like getting emails. So when you're building these real-time apps, it would be nice if everything could be done in one thing, but it tends to require a couple of different components to make the whole thing work. And that's a team, and we'll cover a little bit of the team. Last year's talk, we went through all the backgrounds of Pulsar, and you could look that up. I didn't want to rehash all that material, but I'll cover a couple of key points just so people have some basics that are kind of important. When we're doing streaming with Pulsar or with Kafka, you have a couple of things that you need to define. When you're sending your data around, it's called a message. It's the data you have, which is the value of the payload, and that tends to be in raw bytes and maybe could be a string, and it'll have usually a data schema associated with it, unless it's some kind of binary data, PDF, an image or something, but tends to be something that looks like a record, JSON, Avro, protobuf, those sort of things. And then a key, really helpful, so you could identify things. Maybe a couple other properties, some metadata you might want to track without messing with your data. The name of who made this message, who put it into the stream, just so you know where it came from. Important for tracking, auditing, debugging, that sort of thing. And internally, it'll give it a sequence ID. So if you want your messages in order, it can be done. Very important. Now, we mentioned it's binary data, so we got a schema. This is really easy to do in Python. You just create a little class, and that'll create a schema for you, and that could be Avro, protobuf, or JSON, whichever one makes sense for you. Tend to do JSON because that works with every technology in the world out there without too much of overhead, pretty simple. Now, when I want to talk to a Pulsar cluster from Python, I've got 4 different ways to do it with my 4 pictures of my cat. We could do MOP, which is MQTT. A lot of people in the IoT space like to do that, and that's a great place for Python. We do it AMQP. That is RabbitMQ. That's also something we could do from Python really easily. KOP is Kafka, again, another library with for Kafka available. And Websockets, pretty trivial from Python, but also doable from web pages, which gives you some pretty cool ways of communicating between Python apps using web pages, which is pretty cool. Now, support for those protocols is deep. It's not like a sidecar or some kind of translator. It is a full implementation of that, so you've got the full support there. So feel free to use the protocol you like using. The Kafka protocol is pretty standard industry-wide. If you learn that protocol, learn those libraries, you could pretty much talk to any messaging system. So it's not a bad thing to standardize on. If you're doing Pulsar, besides using Python, you could also use Java and Go. And there's a ton of different connectors. So if you want to get data in and out of your stream, very easy to do. And it makes for an easy way to move data between different applications, different languages. So I can write my Python app and someone else can write Node.js, so I don't have to rewrite their app. I don't have to learn Node.js to talk to them. They could send things into Pulsar or Kafka and I can read it on the other end. And that makes things a lot easier. A lot of different application developers and groups can work together. and not have to worry about a common language, set a schema, put things into topics, and people can use them. And you could have apps in all those different languages at once without a problem, which is a nice way to do it. Now, the thing that's different from last year's talk is we're going to focus a little on Pulsar functions. These let you write bits of code that get executed automatically for you. And you can write them in Python, which works out really nicely. What's nice is on the fly, you could decide what topics come into these functions. So you can write a function one time and have multiple people use it without having to redeploy it. Wow, any changes, I just add another topic to the list that comes into this function. And then whenever an event lands on the topic, it gets automatically sent to this function, execute it within Python 3, and does whatever your function does, which could be output to the default output topic, which you could change on the fly. Pulsar can also let you create a new topic dynamically based on the data coming in and send it there. By default, you can assign a topic for logging, so you don't have to worry about trying to read a file somewhere. You can put it into a topic, and then you could write code to read your errors. So it makes it very easy. You don't have to worry where is the file system, or you could push them into some third-party system. Very easy to do that. I have an example of a machine learning function I've done. What's nice with Pulsar's support for functions is it supports any library that you can install, and it's part of the packaging up. You just package it up as a regular GitHub application, and you put your requirements text in there for all the libraries you might need, and you just use them as you would in a normal Python function. So this means any library you can pip install and runs on the platform that you're running Pulsar, which is most of the platforms out there. You could do Mac, even M1. You could do all the Unixes, Intel, AMD, different NVIDIA works on. You know, you could run these things anywhere. So just be cognizant of that, so you know, hey, I'm running on this platform, I'm running on a different platform, not a big deal. So this is a function, not much to it. Again, we import a couple things from Pulsar. For me, I'm using the Vader sentiment library to do sentiment analysis, obviously a simple one. In some future talk, maybe I'll do some of the stuff around GBT, so we could have even more interesting things in there. Obviously, Python's really great for that. So we set up a class. It's related to that Pulsar function. We have an init. You can do some initialization in there. I don't tend to have much in there. Then our main function and the main part of where your code happens is in this process. And input is the event or message coming in from that topic. And context gives you access to a context for Pulsar. This is how I can get access to shared variables. This is how I can write to a log. This is how I can create a new topic, send a message to a different topic. Lots of stuff in there. Makes it really easy because it's in that one class, pretty easy. So here I've got JSON. I'm not using a schema for this one because I'm getting my data from a web app, and be kind of messy trying to create a class within JavaScript and then having it sent through the WebSocket API and then landing in here. So I'm just having it send JSON, which works great for web pages. Pull out the fields in it. Great thing about Python, very easy to do that. And then I initialize the sentiment analysis on the comment field, and I'll show you this in my live example. And then I return back a couple of values. Just a message ID is the ID of the message that came in. Just a great way to identify what it was. And then I put the sentiment in a new field, add the original comment, send that back as a string. As you see, if I do a return here, this will return to whatever that Pulsar function is mapped to. So I have an output topic that's mapped to whatever one I want it to be assigned to, and it'll go there. If I wanted it to go to multiple places, I could just use the context to send it to multiple places, which makes it pretty flexible. This is also Python. I can write to a database here. I can do lookups. It's Python code. Now, you don't want it to be too large because it is one function, and this is happening each time an event or message comes in, and that could be very frequently. So this could take a lot of horsepower, and we try to keep things lightweight in here. If you want to do things more heavyweight, I would suggest doing PySpark or PyFlink, doing it in one of those, or with Ray, something a little more distributed and ready to do heavyweight processing. This is for lightweight things like I'm just doing sentiment on a field, pretty straightforward. Now, if you haven't used Pulsar with Python before, very easy. We're up to 2.11. Do your install. This works on every platform. For a while, you had to do a little extra work for Raspberry Pis, but the community fixed that. This should install on pretty much any platform you have. Mac, Intel, Mac M1, M2, Raspberry Pi, Ubuntu, Intel, all the different places. If it doesn't, you may have to build the C++ client, and that includes the Python one as well. Again, so this thing is extremely fast. That code I just showed you is in this GitHub for sentiment functions. Pretty easy to get to. Now, once I've installed the library, the first thing you want to test to see that you can send a message, because that's pretty much the critical part of Python with Pulsar is send a message. I mean, why else do you have a messaging system if you can't send one? So connect to it to say if you're running the local standalone one, or you're connected to Docker, you'll just connect to the local host. 6650 is the default port. You could change that for whatever makes sense. I'm going to create a producer, connect it to a topic, and then send a message. This doesn't have any schema. This is just to test the real basics. So persistent means this message is going to be stored as long as I have space, and as long as I decide it shouldn't expire, or I decide, you can decide messages get deleted as soon as someone reads it and acknowledges it. Lots of options there, but by default, we turn on persistence for this topic, put it under a tenant and namespace and in our topic name, send the message, close it, we're ready to go. You can also send this asynchronously. The speed of these are pretty quick. Really depends on your use case. If you want to do them sync or async. If you're doing less than 25,000 messages a second in your app, probably don't need async, because then you're buffering things. You know, it depends on your system. For most people, just send it async until you need to do otherwise. Now you're going to say, how did I? There's no security there. Obviously, in the real world, you probably have security. It's necessary evil. It is not hard, though, with the Pulsar Python library to do this, though. Now, if I wanted to connect to, say, the Stream Native Cloud, which uses SSL, as you can see here, and also uses OAuth and a private key to log in, doesn't take much extra work. I use the authentication library from Pulsar, parse my arguments, and pass them along when I create my Pulsar client before I create my producer. Pretty straightforward. Information is linked below, and then boom, you're sending stuff to your cluster. Now, if you don't want to send just raw strings, UTF encoded, or some binary, you could use schemas. We mentioned that before. If you want to do an Avro schema, you just import it. You create a very simple class of the records from the schema, and it's just the name of your field, case sensitive, and then what type it is. You'd also put nullable in there as well. And then you just create one of these, set the values, and send it. Here I'm also setting a key, like we mentioned before, and a property. And you see we link to our schema, so it knows what schema it is. And again, there's the topic. Now, because If this is the first message I sent and it's never had a schema before, it will create a schema, put it in the schema registry for you, and now it's a contract for anyone reading it on either end. They don't have to do any extra work, whether it's a Python, Java, Go, or some other client, Flink, Spark. They will get this in the right type with the right fields, and it gives you a check. If you tried to send something that's not this schema, it's not going to let you do it, which is nice. That'll fail. That is very helpful for you. It supports versioning. So if you decide, ooh, I missed a field, add a field, send the message. Now it's for the next version, and it'll keep versioning it up. You know, there is some things. Do you remove fields, backwards compatibility? Versioning of schemas can get pretty complex and maybe a little difficult. Maybe you don't want to play around with that too much. Keep it simple, and then you'll be in a happy place. You start messing around with schemas too much, and things will get really weird really fast. So keep it simple is the best way to go. Since Pulsar supports millions of topics, if you're going to drastically change what the data looks like, maybe make it so different that it doesn't make sense to use it, I would say just create a new topic, you know, and that way if multiple people, like I have one version that's Avro and I send it with the Avro schema, and another one where it's Python, and just name them separately or put them under different namespace, different tenants. Lots of options there. So you could see when I do it with JSON schemas, not very different. You know, it's just a different name. You could use those same classes. Like I said, you could use both types, use one class, turn it into the right type of schema, Avro or JSON, and send it to do two different topics with the same data if you need it. Some people may want it in JSON. Some systems might need it in Avro. Say your Flink wants it in Avro, but your Spark needs it in JSON, and your regular apps want JSON. Boom, send it to both super fast. Examples down below. Now we showed you building a producer. I gotta change that to say consumer, because you can see here we're consuming from a topic. So we subscribe, give it a subscription name. Now you could also give it a type, because there's lots of different ways to subscribe to data in Pulsar. We mentioned that before, but by default, it's going to be shared. So if I run this app 10 times concurrently, they're all going to consume from the same subscription, same topic. So if 1,000 messages come in, I'll grab 10, they'll grab 10. So we can run concurrently and process fast. It won't be in any order, but it'll be fast. Again, those are options you could set. Here, I'll just do an infinite loop and keep consuming. I get the message with receive, then I acknowledge it. Once it's acknowledged, the subscription gets it acknowledged on the server. So if I need to expire the data or even delete data, I can do it now because it's been read and I acknowledged I read it. Now, I don't have to acknowledge it. I could just read it and not acknowledge. So it'll sit there as if it's unread, kind of like a message in your email box. But if I need to, if I run out of space, then we're just going to start taking the older ones. Acknowledge it. You can acknowledge one at a time. So you get a message and you look at it and you go, ooh, I don't want to handle this. You don't have to acknowledge that individual one. It doesn't acknowledge all of them in order. You can acknowledge one, then not acknowledge another, skip a couple. It is very specific to the pointers there. So that makes it pretty easy, which is nice. Now, I had ChatGPT build me a Pulsar function, and it seemed to have done a pretty good job. Now, with this one, I wanted it to read data from ScyllaDB, and then I write it to the output of the function. So this created two classes for me, using from Scylla to read user class, and then it created one, a Pi schema for it. So it's reading from Scylla, putting it in this model, and then creating a schema for that. And it's written it correctly with the different types for me. So the function will run, gonna give me a good name. ChatGPT is not good at naming, but what are you gonna do? So I get to self, get my message in, context like we showed before, connect to Scylla. You probably want a connection pool or some other way to connect it, but this works. So we connect, we parse the data that came back. We load it into my user schema. I get the value back from Scylla. I set those values in the schema, and then doing a return in this function, we'll put this into the output topic in Pulsar. So pretty easy way to do that. Kind of cool way to do, like, say, a Scylla lookup, get the results, and then put that in another message. Very easy. This could just as well be a relational database or anything else. It's so easy. ChatGPT wrote that for me. We could send messages via MQTT to Pulsar, also to MQT clusters as well. Paho is the probably the best library out there for Python. We import it, connect our client, connect to a server. In this case, it's Pulsar 4883. There's also, you can use SSL, you can use logins. Like all messaging systems, there's lots of security, authentication, authorization stuff you could set up if you want to. If you're running on your laptop or in Docker, probably not. Here I connect to the topic. You can see that's the Pulsar format because it's actually MQTT to Pulsar. Doesn't really matter, but pretty easy. Send my payload, give it a quality of service attribute, and say retain the message after we send it. So this will expire later and not immediately. Now, if I want to send messages via WebSockets, again, very easy in Python. Install that WebSocket client, import it. Now, there's one thing specific to Pulsar. It needs to base64 encode the actual message that's part of that WebSocket communication. So as you see here, I take the bytes, I base64 encode them, and I put them within the JSON that I'm going to send there, plus some other properties and a context. And then I send that with the WebSocket send, get the results back, and it'll tell you success. If on the other end is another Python app, you can communicate, or you can communicate with a web page, which is very cool, and I'll show you that in a bit. Now, we could also send messages from Python to Pulsar or to any Kafka compliant messaging broker using the Kafka Python library. Very simple to do. Import the producer, import the errors, get my data, connect to my server. 9092 is the default port. Obviously, if I have authentication, authorization, SSL, multiple servers, there's more stuff to add here, but the basics are the same. Send your data to a topic, and here we're encoding it UTF. Flush it out of the system so it doesn't buffer it, which if you want to send a bunch of messages at once, you could do that. Pretty easy. Now, if I want to deploy that function that we wrote for sentiment, you could do it from a GUI, depending on which one you use. There's an open source one, and Stream Native has one in their cloud. Or you could do it from the REST endpoint, or the simplest is with the administrator command line interface, which can be automated with any of your DevOps tools. Use the Pulsar admin. Under functions, I'm going to create one. I want auto acknowledgement true. So as soon as I'm done running this, it gets acknowledged. I don't have to manually do anything. Point to my Python code where it's installed. Put the class name in there. Input is as many topics as I want, and they can be wildcards and other things in there. Log topic is, if I write to context.log, that's where it's going to go. Nice way to log without touching your disk, and you can easily distribute it to systems to make it easier to debug what's going on. Set a name that'll show up everywhere. Give me an output topic, or like I said, you could add your own outputs dynamically inside, depending on what makes sense for your use case. We got a link to the source code there if you're interested in seeing the whole source code and trying it out in your own system. I have an example application that's really simple within Python, but we'll take a look at that. and there's a little article around it. So I'm reading from the FinHub Stock API, which has a WebSocket interface. Again, very easy in Python. I read from all these stocks the current values, and they get pushed back to me. When they get pushed back to me, I send it to a stocks topic, and then we can query that data with Flink or Spark, or just read it with another Python app. You know, I can read it within a Jupyter notebook or whatever you're going to do it. Pretty straightforward. Now, again, for stocks, very similar to what we saw before. I said, because I'm going to read this in SQL later, I put together a schema here, and it's got all the fields I want. And again, specifying the types that make sense for the data coming in, strings, floats, you know, you could do Boolean, bunch of things there. Connect to my cluster, connect to that topic, make sure I'm using that schema, put an ID in there, and then I could start sending data. Here I'm generating my primary key and UUID internally. I like to use UUIDs, and here I put a time in there, so it's a pretty big, pretty close to unique, not perfectly unique, but close enough. So I read the stuff coming back from the WebSockets, set all my record values. If the stock wasn't null, I mean, sometimes you get some bad data in WebSockets, send that out to the topic with that key, and we're ready to go. I don't know what happened to that page. This is an example, and I'll show you the live code and how we do it. But this is an example of a web page I made that reads makes a WebSocket call to Pulsar and get back the data. Again, what's nice is I can have Python populate this data real time, either pushing it to WebSockets or push it into Pulsar, and let Pulsar act as that gateway for me, whichever makes sense. If I'm not any way connected to where this web server is, putting it through Pulsar is nice. So you can have your data come from any place, you know, results of machine learning or whatever gets pushed right into your system for you. You don't have to worry about cross security and all that kind of stuff. So the web page, I'm not a front end developer, so it is not the most beautiful thing you've seen in your life, but it works, and it is very fast and just keeps continuously getting more data, which is nice. So I'm using the data tables JavaScript library with jQuery. Pretty easy to do. That's all documented at this transit function. And you just create a really simple table. It does have to have a head and a foot, and this is going to be the title for the table. And using that ID there, we're going to push in data as it comes in. Pretty easy to do. We connect our data table, connect to Pulsar here. This is our consumer string. Connect to our server. Pulsar has 2 ports. One is a REST point that we use for this communication here, as well as doing admin stuff. And then we point to, we say we want to be a consumer of this particular tenant, namespace, and topic. And I create a subscription here and say what type of subscription it is. That'll look similar to what we did with the regular Python consume code. Create a WebSocket, log it if you want. Errors, display those, pretty standard stuff. When the data comes in, if it's not null and everything looks good, I'm going to parse it out. Again, I mentioned that base 64 encoding. We unencode that. If it's still good, all I have to do is reference all those values that came through from the sender, add it to a row, shows up in the table, got an article, shows you that. What's nice is we have that schema defined. So when it comes through, again, this has to be JSON, it automatic for you. You get all these field names. You don't have to worry about, you know, hand coding, hand parsing things, or doing some weird decryption or trying to figure that out. Just does it for you. That is really nice feature. Now, I also wanted to mention another place that we could do some pretty awesome Python coding. If you've seen some of my other talks, I might have shown an open source tool called Apache NiFi. This is a WYSIWYG web tool that lets you do data flows by dragging and dropping boxes. And then they build a pipeline of data for you. And it's really awesome. But if you had any custom code you wanted to do, we either had to execute out Python remotely or call a REST endpoint or go through some kind of Java interface. And it was, it wasn't as clean or as nice as you would like. In the next version of NiFi, you can now do Python custom processors, which is probably going to be my talk for next year. Should be production then and be pretty awesome. This lets me add to a flow any bit of Python code that I want. Pretty clean, like you see here with initialization, different events, pretty straightforward. And I could use all the libraries out there that make sense, including machine learning and deep learning. And it runs it in a protected space, runs it very quickly. It is a nice way to integrate. I'm very excited to do this because this takes my Python app that I could just run normally and distribute it for me. I don't have to figure out how am I going to distribute the execution of this? How do I make it run on a cluster? How do I make my Python script available to run in different cloud environments, wherever I'm going to run my standard data pipelines for real-time streaming? This will distribute it for me. This is a great time saver for us and gives you all the benefits that you have with auditing and queuing and all kinds of fun stuff there that we do with NiFi. I'm going to go show you the demo now, and hopefully everything is running and cool. If you're looking for source code before these slides come out, just go to my GitHub, tspanhw. I've got every example on using Pulsar, Kafka, NiFi, Flink, Spark with Python, all kinds of different places on a ton of different Raspberry Pis, on NVIDIA Jetson, all kinds of devices. So check that out. Let me get to the source code. And there's a couple different places we have that running. Let's make sure we got everything we expect everywhere. That's somewhere else. Hold on. Now we have the stocks example right here and very easy to get to. So if you want to see that, we'll show you that later. Let's get to the thing I was talking about the most. And this is the chat app. Again, regular web page here, nothing too unusual. If I go to source here, I'll show you the source. It is just a web page. Let's make this bigger. Hopefully people can see that. Really basic HTML. I'm not a front end person. It's just a form, submits to itself, has the data tables and jQuery. We connect to our Pulsar thing. This is where I'm going to send my chat data. And then I'm going to get the results back in another table down here. That's a consumer. So in this app, I am both make it a little smaller. I am both the producer up top and the consumer at bottom. So I've got a live app that's talking to two different Pulsar topics. And what connects them is that Python function that's taking the input of my text here. Why is the Python web conference so awesome? Well, the shirts are pretty good. If you didn't get a shirt, I highly recommend it. So we send that message. Let's make sure we didn't crash here. Let's do that. Why? Oh, it's down here. We see it came in, but we'll do it again. Let's see. Does it think that's a positive sentiment? Tim at the conference. So we send it and we see here. It seems like I'm just posting from here to here, but this sends, if we look at down here, we've got produced, sent it to that WebSocket. That WebSocket got translated into a Pulsar topic. It landed there, executed that Python function. That function put a new message in the result topic that we're reading down here, and it showed up. and it's that fast running on my laptop. You can see it's sub-second. And we could connect thousands of these. If you needed bigger clusters, you could expand it out. But really easy way to have data come from a web page, go to a distributed messaging system, do some analytics, whether it's machine learning, deep learning, or just regular code, get sent the results back to a distributed topic that I could read here and could also read in a Jupyter notebook, in somewhere else without too much pain there. Very simple. Why is the conference almost over? Let's see. Does it get that sentiment right? Yeah, it's negative sentiment. If I can't wait for next year, that's neutral. Will be awesome. How about that? Again, I'm excited to see if I could have NiFi call Python and that Python have some chat GBT in it. Maybe connect to a chat system here where you ask your question. We run a couple different analysis on it. Maybe hit some custom trained models, get the results back, push it here, push it to Jupyter Notebook, push it to another app, maybe run it in a SQL query. Pretty straightforward. It's just a pretty easy way to connect Python to live web pages and run some stuff in them. Pretty easy way to do it. I can pretty much deploy any model. Obviously, if it takes an hour to run your classification, probably don't want to do that real time, but a lot of options there when you're running it. And again, here, I just check all the fields before I publish them and put them in here, just so we don't put empty stuff in there. It looks a little weird. But yeah, it's pretty easy to do this, and it's not not too hard. Obviously, it's a very simple sentiment analysis. We could do whatever makes sense there and is interesting. And within that NiFi, so what I could do right now is I can execute Python very messy way. I could just call a process or, a shell script wrapping it. Or I can use JPython, which if any of you've tried it, is not the best. So what we'll have is we'll have regular Python here, and these will be custom. So I'll just grab any of these features here. Like I have some for deep learning, but I'll move those to Python, and then I could have that as part of my flow, and it gets all the features of NiFi without having to not write it in Python. All the scheduling, execution on all the nodes in the clusters, as many tasks as I want per cluster, node item, any custom properties. Plus, it will get all the advantages we have in NiFi, which is being able to start and stop things real time as they happen. So say I'm running this data here, as it's coming through, I can see it live auditing of that data as it comes through the system, and your Python app will take part of this. It will produce any of the metadata, and that'll show up in our instant auditing. So you'll have full lineage of it, and you'll just get that data as input to your function. You see here, we can pause things real time. Like if I stop this, I can also rerun things. If you want to test data you have, just do a replay. And now it's waiting here because I stopped it. It's a nice way to be able to execute your Python in a distributed manner without having to think about it. Of course, once I send data here to Kafka or a Kafka compliant messaging system, your Python app, if it's using that consumer API, which we showed you, let's get to that one. Let's see. Yeah, this is the consumer. Let's change that on. Yeah, so if this app was sitting there consuming messages, this send from NiFi to that topic, if I'm consuming that topic, that's going to show up in that reader instantly. And it could, at same time, could show up in Flink, could show up in other Kafka readers, real time. Very easy to do that without a lot of heavy lifting. I think we're close to time. Do we have, I'm trying to look on the chat here, see if I can see some questions. I don't see any. Let me check and see if there's any on the Q&A. Don't see them. Generally, questions we've had in the past are, how do you get started with this? How heavyweight is it to install? That sort of thing. Pretty easy. We could run it right in Docker. There's all the stuff you need to run in your own Kubernetes environment, or you could just run a single standalone node, and that'll support a lot of messaging. Very easy to do, not too hard. I hope you liked my talk. If you have any questions, definitely reach out to me on Twitter, Slack, LinkedIn, at the meetup group, on GitHub, at my website. I've been Tim Spann. Thank you for joining me. Hope I see you next year.